In section 5.3, we're going to graph general rational functions. So we talked about the simple rational functions where we found the h and the k, and we could plug them in, for the vertical, horizontal, asymptote, domain, and range. But now we're going to take a look at just a general rational function. And we have a couple of scenarios here that are listed. And we're going to talk about each one of those. So the first one is saying that we're going to have this m and n quantity. So for example, let's say we have f of x is equal to x squared over x. When we talk about the m and the n, our m is going to be the exponent of the numerator. The n, well, this will be a 1, will be the exponent of the denominator. So when you see the m and n, that's what they stand for. So I'm going to make a note here that m is exponent. Actually, I should say that that's the degree. So the m is the degree, which is the highest exponent, of the numerator, where n is the degree of the denominator. Got cut off there. So if we take a look at the first one, we have that if m is less than n, that the horizontal asymptote is y equals 0. And this would be for every single time. The second one is that if they're the same, if the degrees are the same, the horizontal asymptote is going to be your coefficients of that degree. And then the final one is if m is greater than n, there is no horizontal asymptote. So we're going to take a look at each of those individually. So the first scenario, where m is less than n, and your horizontal asymptote is going to be y equals 0. So if we take a look at some examples, say we had f of x is equal to, let's say x squared plus 5 divided by 3x to the 5th minus 7. So in this function, we are looking at the degree of the numerator and denominator. So the degree of the numerator is a 2. Degree of the denominator is a 5. So remember, the 2 in the numerator, that's your m. The 5 in the denominator is your n. So since the n is bigger than the m, we are not looking at anything else. So this 2x, or the 2 and the 5, and then this 3 and this negative 7, they do not matter. You are looking at your m is less than n. And since that exists, your horizontal asymptote, your HA, is y equals 0. So you're only looking at those degrees. Another example of this would be if we had f of x is equal to 5 divided by x squared plus 100. Okay, again, it does not matter, what this is. We are looking at your degrees. So in the denominator, our degree is a 2. In our numerator, we don't have a degree, so that is going to be x to the 0 power. So since 2 is bigger than 0, your m is less than n, this y would be equal to 0, which is the horizontal asymptote. So you're only focusing on those degrees. That is for the first scenario. The second scenario is when the degrees are the same. So if you have m equals n, the coefficients of the degrees would be your horizontal asymptote. So if we look at an example of that, say we have f of x is equal to 3x to the 5th minus 1,000 divided by 2x to the 5th minus 8. Again, nothing really matters right now for the horizontal asymptote except your degrees. Since they are the same, the leading, the degrees, the highest exponent, they are both 5. Since they are equal, m equals n, your horizontal asymptote is going to be your coefficients. So y would equal 3 divided by 2. take a look at another example. F of x is equal to x minus 7 over x. Okay, so we're going to look at the degrees. They are both a 1. Remember, if you don't see a degree, it is assuming it's a 1. Since they are the same, our horizontal asymptote is going to be equal to the coefficients, which are 1s, so y would equal 1. The final scenario is when the m is greater than n. This would have no horizontal asymptote. And eventually, when you get into your next class, the trig pre-calc, you will talk about oblique asymptotes, and that's where this will come into play. But we will not get to that in this class. So say we have an example of f of x is equal to x to the third power over x plus 7. Again, we're only focusing on the degrees. So the degree on the top is a 3, the degree on the bottom is a 1. Since 3 is greater than 1, m is greater than n, so this horizontal asymptote, you would have none. And we're going to write none. You don't write 0 because 0 would be, an actual asymptote. Another example, say we have f of x is equal to 5x to the 5th power minus 75 over x cubed plus 4. So looking at the degree, in the numerator it's a 5, denominator it's a 3, so since m is greater than n, the horizontal asymptote is equal to none. All right, so when we go to find these pieces of information and graph them, we're also going to need to find the vertical asymptote for this general rational function. And all you're going to do is you're going to set the denominator equal to 0. So we're going to take a look at an example. This is going to be example 1 from the notes. And we have that f of x is equal to x squared minus 9 divided by x minus 4. We're not graphing at this point. We're just finding the pieces of information. So the first thing we're going to start with, I'm going to say is the horizontal asymptote. So I'm going to look at my degree. I have a 2 in the numerator. I have a 1 in the denominator. Since my n is greater than n, there is no horizontal asymptote. So my HA is going to be none. Now to find the vertical asymptote, I'm going to abbreviate with VA, we're going to set the denominator equal to 0. So I'm going to take my denominator, which is x minus 4, equal to 0, and I'm going to solve, which will give me x is equal to positive 4. So my vertical asymptote is 4. And then to find your x and y intercepts, what you can do, if we're not using a calculator, is we're going to plug some zeros in. So if I wanted to find my y-intercept, what I'm going to do is I'm going to plug in my plug in 0 for every x that I have. So I'll have 0 squared minus 9 divided by 0 minus 4, which will just end up with 9/4. So my y-intercept would be x is 0, y is 9/4. My x-intercept, to find that, you are going to take the numerator and set it equal to 0. So we're going to take the numerator equal to 0. And the reason is because if you take your function, your x squared minus 9 over x minus 4, and set that equal to 0 to find the x-intercepts, I'm going to put 0 over 1. If we cross multiply, it will just turn out that we'll have x squared minus 9 equals 0, which is your numerator set equal to 0. So we can solve for that. We can factor it out. You can solve by using square roots. So our x-intercepts are going to be 2, which is negative 3, 0, and 3, 0. Let's take a look at another example. This is number 2 on the notes. We have f of x equals x plus 3 divided by x squared minus 2x minus 3. So the first thing I'm going to do is I'm going to find my horizontal asymptote. identify my degrees. Since the degree in the numerator is smaller than the degree in the denominator, my horizontal asymptote is y equals 0. Next, I'm going to find my vertical asymptote, which means I set my denominator equal to 0. And we have a quadratic function, which means that we're going to set that equal to 0, and we're going to factor it out. So we need two numbers that multiply to give us -3, add to give us -2. This will work out nicely, -3 and 1. So we have x minus 3 times x plus 1 equals 0, which will give us x is equal to 3 and x is equal to -1. So this graph has two vertical asymptotes. And then to find our x and y intercepts, I'm going to start with my y-intercept. Remember, you're going to take your function and you're going to plug in 0 for x. So we have 0 plus 3 over 0 squared minus 2 times 0, which is all 0, minus 3. So if we solve that, it will be 3 divided by -3, which is -1. So a y-intercept would be 0, -1. The x-intercepts, or x-intercept, we're going to set the whole function equal to 0. And in the previous slide, I had said that you're just going to basically take the numerator and set it equal to 0, because when you do all of this, you cross multiply. It's just your numerator equals 0. So our x-intercept would become -3, 0. So we found the horizontal asymptote, the vertical asymptote, the y-intercept, and the x-intercept.